everyone, bună dimineața. I'd like to thank Roman for breaking the ice a little bit for me and getting you a little bit hyped up, and hopefully that's what I'll do following now. To be honest, being here on stage right now is quite remarkable and humbling because I'm just a developer like you guys, and I have this opportunity now to speak to a large audience of professionals. And it's also intimidating because you take a developer and you take him out of his natural habitat, put him on stage. Some things might go wrong, so if you see me stumble, please help me out with some applauses. That will surely help me. Awesome. I actually want to set some expectations for this speech. It's not going to be a deep dive into any particular topics that I'm going to present. Rather, I'm going to tell you a story about one opportunity that I had in Stefanini lately, which led to a lot of growth for me and a lot of understanding of new topics. I'll get to it in a bit. Probably I should have presented myself a bit first. Alexandru Marinescu is my name. I've been a developer at Stefanini, a senior developer at Stefanini for the past 5 years or so. And in total, I have about 10 years of back-end development. I was actually curious about the stage and about the audience now. How many of you are developers? I know it's called the Moldova Developers Conference. It should be interesting. Okay, so quite a bunch. And back-end developers out of these? Okay. And maybe even lower, like .NET back-end developers? Cool. All right, all right. Well, everybody gets their 15 minutes of fame, so this is me trying to present to you guys. And the story I promised, it was an opportunity at Stefanini, started at the beginning of this year, actually. And this is the technical story that I promised. We had a project to do. My manager came to me and said, hey, we have a strict budget, we have a strict deadline, obviously. So we need to deliver something great, something that will wow the customer, obviously, so that this first step that happens can lead to others. And what am I talking about? We had a very important client from our country, a parcel delivery company. We had their clients on the other side, and a new system for them of delivery boxes on the street. Maybe you know them. I haven't seen any in Chișinău. But maybe you know what I'm talking about. Those where instead of ordering at work or at home, you can get your parcel directly from a box, all right? That was new for them. We had to come up with everything from the start. So everything was at ground zero. So we got to work on the design of the application, me and along with 2 other senior colleagues. Just for the back-end part of it, okay, there were other parts of the application, even the tablet that's on the box there. And with most of the designs done by our business analysts, we got to work. And this is what we started with. We settled on splitting stuff a bit, okay? So we made 3 APIs there and a 4th one to help with security and so on. Actually, for this 4th one, we went with an off-the-shelf solution from Microsoft, an Identity Server 4, which in hindsight now would have is probably an overkill. But we didn't want to roll our own crypto. You know, whenever you hear that, you should be suspicious of what they're doing there. We went with something that provided security, was a reputable vendor, okay, and from our initial estimations, we had a lot of upcoming management of users, so we went with that on that side. Now the important part, the center of what I'm going to tell you, are the other 3 APIs, which one of them serviced and talked to the parcel delivery company's server, one for their portal where they can administrate stuff, and the third one, the sink, is the one that communicated with all the boxes on the street. We chose probably the latest technologies that we had available then. We had an on-premise SQL Server 2019, .NET Core with Target Framework 5.0 at that point. Now there's a 6.0 now. We made full leverage on the DI framework that is built into .NET Core, leading us to a fully testable solution, unit tests, SignalR for what we had to do to have this two-way communication with the boxes and some other parts of the application. Entity framework, haven't put it here, but we use that entity framework core. So we built everything with Docker in mind, so it was easy to deploy locally, it was easy to deploy on a server for QA and so on. And yeah, that's what we went for. Before I start with the plot of the story, again with a raise of hands, I want to know, do you think that was a fair approach? I mean, would you have done the same? Not maybe at an individual component, but as a whole. I don't know. This is what we went to at that moment. There were no major objections between the team members, and we thought that's a great way to approach this story. Now, the gist of the whole speech that I came for you here is that all those three APIs, we build them on this N-tier layered way of structuring the application. Pretty standard. At the very top, we had the presentation layer, basically the controllers, which called down into business logic, which then called down into data access. There was some validation there in the business logic, and that got and did updates and queries to our data store. And you might be wondering what happened. Well, it was a successful delivery. I mean, the client was happy. We pushed the very first version into production. It's working. People can successfully get their parcels and hopefully not somebody else's parcel from the box. They were happy. We were happy. Everything was fine. It was actually fine, right? I'm just joking here. It was really great, but there is a but. The lingering problem that we had was that at some point we had a lot of business logic related to the type of package that was being sent to us from the client system, and we had to distinguish at the parameter levels if this is an update of this sort, or this is one workflow or another workflow, and we caught on technical debt. Okay, it got hairy really fast. And by the time we noticed this, there wasn't really much to change at the core level. Of course, we did as much as we could to tackle the technical debt and to leave the code as consistent as possible. So bad code is bad code, but it's even worse when it's not consistent, right? In the future, when we might refactor that, at least everything looks the same. We know what to do. Also, this problem stuck with me in the back of my head. And for quite a while, I wondered what could we have done differently? What could we have changed in order to make this a lot better, a lot more future-proof, better performance, and so on? And throughout my investigations, of course, I found a lot of good ideas to do. But the one that I thought that deserved the presentation in itself was the following: using CQRS with event sourcing and domain-driven design. I put up on the screen now a few definitions. Again, I'm not going to go into details, but everything put together gave me an aha moment for what we needed to do. Simply put, CQRS separates commands, so if anything that we do to update or create an entity, we call them commands. Everything on the other side is is for querying. And right from the definition, I see a few things that are very interesting to me. We can maximize the performance, the scalability, the security, okay? And over time, we have a far better product that is future-proof, okay? Why didn't we do that? Now, event sourcing, right from Martin Fowler, his definition is spot on, simple. We capture all changes to an application state as a sequence of events. What this means that, in our case, the parcel, you don't insert, update, or delete. You just have piling events that happen to that entity. Entity created, entity updated, entity moved, and whatever the main event you might want to declare for that one. And this is where the third part comes in place, this domain-driven design, which I think it's inherent for all of us. I mean, when we start off from, when we start working on an application, most of us think from the domain side of stuff. And when you think from that perspective about your application and you form the software around that, essentially that's what domain-driven design means. This has an effect on people. It changes their perspective. And going through documentation, going through websites, going through books, reading on this topic, I really thought that, I was stuck in a particular mindset, hence the title of my story. I was stuck in this layered way of doing applications, and I didn't know better, okay? And actually, when you start applying event sourcing onto systems and start designing them, you put the behavior first before the actual layout of the system, before its structure, okay? And that, moving onwards, will actually change the way the domain experts look at that particular topic. In our case, for example, or maybe let's take an academic one. When you create a basket and put an item in it, and then the client clicks buy, you maybe don't want that application to validate that we have that item in stock and we have a large amount of items that we can pick from. We just, as a system, we just want to process that request, record the events that happened, and maybe we can deal with this problem later. And it's exactly what I found during all of this, was that simple stuff like validation that the entity exists when I want to update. That's not so trivial anymore when you think about it from the event source point of view, domain, and so on. I can just accept that the client called with an update, and somebody else will deal with that later if the entity didn't exist or something else happened, okay? I'm not required to give an answer right then and there on the spot. So, putting it all together, understanding the definitions, my conclusion was that we built that initial system, which was great. It was working as we expected. We built it like an ATM. You know, when you go to the ATM and you don't have cash, you get an error right then and there on the spot, okay? There's, in that case of an ATM, there's no, you won't have the ATM chasing you down the street a few minutes later to tell you that, hey, I didn't find money, you have to give it back to me. But in our case, not all the APIs had to do that, okay? We could have structured them differently. And what does this mean, structuring differently? The system that you saw earlier could have been presented like this. We have, similarly at the top, a presentation layer. Using CQRS, we can split them into commands and queries. Now, validation is a part of the pipeline, okay? Because maybe at this point you start to think of validations as two different flavors. One that strictly validates the input, if the email is correct, if the name is long enough, the username is long enough, and stuff like that. And we can place that into the pipeline of the application. And then there's the other type of validation, the one that's business validation. We can talk about that a bit later, or at least not now, but it should be a talk for later. It should be the part that forms your domain when you do that. Now, the commands reach into the domain logic, and then they reach into the data persistence, where, in this case, if you want to make your application more scalable, give it more performance, you might want to separate the writing from the reading. And I'm guessing you are familiar with NoSQL databases, right? They bring a lot of performance, but when it comes to reads, maybe they're not so great. To write, sorry, maybe they're not so great. Here, in this particular case, there are a lot of software. There is a lot of software out there which specifically handles event source events that need to be stored. They store them in a particular manner. They can be accessed very fast. And there's something that's happening in that store, the way the data is structured, that lets us recreate the entity based off of a timeline, a specific point in its timeline. And actually, that was a part that we needed as a requirement for our project. The client wanted to know a history of the package from where it started to when it was picked up by the client itself. That probably could have been done a lot better using this approach. Now, if you take a very close look between the two databases, you will see an arrow. That arrow hides behind it, again, some logic, because when you have these two split points where one stores events, stores the data, and on the other end for the reads, it gets consolidated, there obviously has to be an actor in between. And maybe I can read from your faces, RabbitMQ, Kafka, Nats. Okay, maybe that sounds familiar to some of you. It didn't sound familiar to me when I initially designed the first application, but it did afterwards, okay? Because now you have a system where you can pretty fast put data in it, put the events, and everybody who is interested in those events can subscribe onto this mediator, let's say, onto this system, and do whatever it needs to do with them. In our case, let's say we had a parcel, it reached the box, we had to send an SMS to the client, we had to inform the parcel delivery company that it got to there, okay? Maybe we want to store some history about it, so we can do a lot of stuff just by approaching this with events. And this wouldn't be a developer conference if we didn't have code on the screen, right? And I'm just gonna go through some examples, and this is not the parcel delivery application. This is just some proof of concept that I used to put everything together and actually see it in action. And we have here a very simple controller, okay? You can see the implementation here of CQRS using the mediator pattern. In this case, we have up there a dependency injected for iMediator. That is being resolved, if you're familiar with .NET, that is being resolved either in the startup class or the program class as a transient dependency, okay? And we have the controllers there, which you can see use the mediator to either send a query or send a command. Like super simple stuff. Now, an example of a command, I tried to fit as much as I could in here. But again, an advantage of using this mediator pattern is instead of cascading our dependencies from layer to layer and bringing everything along with us, now we have in the middle this mediator, hence the name, and when one component needs a dependency, it asks the mediator and he gives it to him. And this is exactly what we see here. We have a lot less dependencies in the constructor of our class, of our command in this case, and a lot less logic. Again, being a proof of concept, not much is happening here, but I would like to draw your attention to the almost last couple of lines where I persist the event on one end, and then I inform Kafka, in this case, that I produced this event. Actually, in this POC, I think I used the cloud-based Kafka, so I send it to the cloud. And on the other end, this is the producer. Nothing much happens here either. It's just that we give it a key, so we find it fast, and then the value is our event. What is happening on the other end is we have a query. We need to get that data somehow. We need it, and we need to get it. And we have an example of a query. Again, simple. The only validation that I haven't created an exact component that to go in the pipeline. I just put it here. But as you can see, we are just validating the input. We're not validating the existence. And we just simply go and get it from our repository. Now, what's happening here, and I have an interesting bit here, which I'll get to soon. This is the consumer. This is the one that subscribes to that Kafka service and listens. Do you have any events for me? Sure. Somebody just created the basket in this case. Perfect. Give that information to me. Using the same mediator pattern, I can send it off to handle added or item added or closed, so I can decide based on the event. But there's one line there with a comment, which I specifically added to mimic eventual consistency. This is a term that you'll find when dealing with such systems, is that between the point in time where I create the event and the point in time where it is being consolidated and created on the other end, we might have a delay. And this is called eventual consistency. This is something that will have to be negotiated with the domain experts, with the business analysts, because sometimes we might be okay with the systems being slightly unsynchronized. Sometimes we need it right then and there. So here in just this proof of concept, simply adding a thread sleep there gave me this, this sort of application. Now, this slide with conclusions, I'm going to do a whole bunch of conclusions here, but I think the very first one I want to focus on, actually trying to go back here a bit, but maybe it doesn't happen. What I'm trying to say here is that you've seen the code. I like it much more than the N-tier one, okay? When you see it all together, all working, all the components working together, the queries and commands being split nicely, the slim fit controllers, okay, one-liner controllers, that's really neat. What else? You send it off to Kafka, you can have multiple subscribers to that. I think we would have built a better application if we knew from the start that we could do this. Building on what I've said so far, I think that we'll be seeing a lot more applications built this way, okay? I think that maybe I want to call it now, I think that in 5, 10, maybe 15 years, we will see a lot of projects where they will have to refactor layered applications into something like this. Because a lot of people think that this is the future of what we do, like in this specific niche. And maybe a lot of companies would like to migrate to that or will be forced to migrate to that, okay? I think that we're not far from the end. I left this post here, actually, from Stefanini EMEA announcing my participation. And the part that I like most is the very first line, which says, a successful career requires continuous knowledge development. And this is why I told you this story, because for me personally, all the topics, everything that I investigated, even a few words here and there, sparked curiosity, okay? It pushed me to chase more knowledge, to better myself, even though maybe some would consider that it was quite late in my career. Anyway, this is what I hope I imparted to you today as well. Go off, research about these topics, see how they fit. If they fit, maybe they don't. Maybe some parts fit in the projects you're working on, and strive to be a continuous learner. Thank you very much.
Thank you, Alexandru. Guys, we have 4 minutes for questions, so please raise your hands and Rafael will help you with the microphone. Yeah.
Hi, actually very nice. Closer, okay. Very nice topic indeed. I do have one question related to the code that you showed. So I saw that you're using a separate event repository and a separate publishing to Kafka. So what are you using as an event repository then?
Okay, I'm going to be honest and tell you that it was the same database behind. But the way I structured the application was to mimic if I would have had 2 separate systems. From what I've read, and I can't produce them now by myself, but I know that there is software out there, and I mentioned this, that specifically does event sourcing, because it's not just about putting data into there. You have to bring it out consistently. You have to recreate maybe an object, a domain entity from one point to the other. So there's a lot of logic that's happening there. That's a subject of a presentation in itself. And on the other end, again, I just had an SQL database with 2 different tables that weren't communicating between each other. But what I strived to do in that proof of concept was to point out that I'm inserting into one table or one place just events, and in the other table they are materialized by a component into an actual what do you call it? Entity linked to other entities, into an actual information we could use.
Yeah.
Thanks you for the question.
Thank you for the presentation, Alexandru. It was really nice. I must admit I didn't understand most of the technical stuff. But I have a question about, you said you had delivered one product, the client was happy, and after you came with a different architecture. Have you already provided to the client this new architecture? Did the client accept it? And how long it took or it will take to implement this new architecture?
There's a conflict of ideas in me related to this question, because I'm not sure who said it, but it went something along the lines of be careful when you restructure an application altogether, because in this refactoring, when you refactor everything, you might lose bits that your clients were using. So I don't think that will ever go back to the client with this specific proposition to rewrite everything right now and then. And to be honest, they haven't said that they need it, okay? For me personally, the project spanned from January to about mid-July, okay? And another part of the team is handling now future iterations. Until that particular system will need more performance, I don't know, more security, stuff like that, I don't think we'll ever go back to them to say, hey, we just had an idea overnight, let's do this. It's going to cost you the same plus some more. In business, I don't think that's going to happen. Any other questions, guys?
Yeah, we have, I think, the time for one more question.
Before I get that one, just a reminder, we have a stand here for Stefanini, and my flight doesn't leave for another 45 minutes. Well, not the flight, but the taxi. So I'll be able to take more questions then and there.
I would like to know, when you have failure in network, what do you do with the data that didn't synchronize or didn't get subscribed to the API or server?
Good question. That's why I led with the phrase that I'm not deep diving into anything. Each part that I presented to you has complexities behind it, a lot of complexities. Actually, designing an application with CQRS and event sourcing in particular actually proves it for clients that are not always connected. So in this particular scenario, if we got the event, and let's say something happens, as you say, on the network between publishing the event and distributing it, there are a whole lot of strategies put out there, even by Kafka, by Nats, and I haven't even mentioned what cloud systems are doing, because everything, you can build such an applications completely from Microsoft Azure, for example, or Amazon AWS. So there are strategies to recover lost data. There are strategies to make sure that at least once, for example, the message got to the client, or maybe we can do one or multiple times, and then the client will have to find a strategy to see if it received that message before or not. So depending on your tolerance towards error in that particular part of the system, you can either push multiple messages when you get online and see how the client deals with them, or you're okay for that client to have lost that just one message. This world is not perfect.
Yeah, thank you. Thank you. That's all for questions. Thank you.
There was no need for claps, right, during my presentation. Thank you very much for having me, guys.